Hello friends, welcome back. In this session, we'll see how to calculate the area of a parallelogram if we know the equations of the sides of the parallelogram. So, we know that in parallelogram we have two pairs of parallel sides. We can see here we have a1x plus b1y plus c1 equal to 0 and a1x plus b1y plus d1 equal to 0. That is one pair of parallel sides. Another one is a2x plus b2y plus c2 equal to 0 and a2x plus b2y plus d2 equal to 0. Now we have to find out the area of this parallelogram by leveraging the distance between parallel lines what we are currently looking into. So for that, first let's step a little bit and try to understand what's the area of what's the area of a parallelogram. Nothing but equal to base into height, or can I say altitude. That's a formula you have for the area of the parallelogram. Now we don't have any lengths, but now we can easily find out the distance between the parallel lines. That we can see because we have the formula with us, that is c1 minus c2 by root of a square plus b square if a1x plus b1y plus c1 and a1x plus b1y plus c2 are two parallel lines. We have that. So based on that I can find out the altitude. So let me just draw them. Let us say this is our let us say this is P1. Also let's try to find out the altitude from D onto BC. Let us say that's altitude. Let us mark this point as X and mark this point as Y, X and Y. Okay. Now let's just substitute in the formula what we have. Area equal to, now we know height is P1, so I can go for AB into P1, or it is also equal to BC into P2. Now we know P1, P2, we can easily find it out. The problem is how to find out AB or BC lengths. For that, we will start with saying that let the angle between let one angle of the parallelogram be theta, and you know in parallelogram opposite angles are equal. So if you somehow we are able to find out AB or BC in terms of P1 or P2, then it becomes very easy because we know tan theta is m1 minus m2 by 1 plus m1 m2, or so based on that we can find out the area very easily. So let's go ahead and try to do that. We will not calculate P1, P2 now. First let us see how to get AB or BC in terms of P1 or P2. Now let us stick to first how we want to calculate the area. We want to calculate the area by A into P1 or BC into P2. Any one you can pick. Let us say I want to calculate the area by AB into P1. You know that AB is equal to CD. And if we consider the triangle, in triangle DXC, we see that sin theta is equal to P2 divided by CD, or can I say P2 by sin theta equal to CD. We also know CD equal to AB. Therefore, area is equal to AB or nothing but CD into P1, which is nothing but equal to P1 into P2 by sine theta. Let me just repeat that. So we can find out P1, P2 because we know that is nothing but the distance between two parallel lines. Now the problem comes how to find out the values of the sides, how to find the measure of the sides, either AB or BC or CD or DA. For that we started with, let us say the angle, one of the angle of the parallelogram be theta. We know opposite angles are equal. Now can we convert the sides either AD or CD into P1 or P2 so that we can calculate the area easily. At the end, remember that our answer should have only whatever the values we have here. It should be in terms of C1, D1, C2, D2, A1, B1, A2, B2. So because this is the only information we have been given to find out the area. Okay, now we understood that area equal to P1, P2 by sine theta. Now let's substitute the formulas each one by one. Area equal to P1. P1 is the distance between two parallel lines, A1x plus B1y plus C1 and A1x plus B1y plus D1. So P1 is C1 minus D1, that's the distance between the parallel lines, square root of A1 square plus B1 square, square root of A1 square plus B1 square, that is P1, multiply with P2 on the same lines, that is C2 minus D2 divided by square root of A2 square plus B2 square into 1 by sine theta. I will substitute here the value of sine theta, but I will explain you how we got it in just a few minutes. Sine theta is nothing but equal to A1 B2 minus A2 B1 divided by square root of A1 square plus B1 square into square root of A2 square plus B2 square. Cancel out A1 square plus B1 square, A2 square plus B2 square. We are left with answer as C1 minus D1 into C2 minus D2, that's a mod for everything, divided by A1 B2 minus A2 B1, because the area cannot be negative. So when we multiply them, we should have everything to be positive. So it is C1 minus D1 into C2 minus D2 by A1 B2 minus A2 B1. Now only the thing is how we got sine theta equal to A1 B2 minus A2 B1 by root of A1 square plus B1 square. That I will explain you. Before that, just let me summarize you. If you understand very clearly, we have said that area equal to P1 P2 by sine theta. P1 is distance between first set of parallel lines. P2 is distance between second set of parallel lines. First parallel line, second parallel lines. And 1 by sine theta. Sine theta is A1 B2 minus A2 B1 by square root of A1 square plus B1 square into root of A2 square plus B2 square. Cancels out, and the formula is, what we get at the end is C1 minus D1 into C2 minus D2 by A1 B2 minus A2 B1. Now let us see how we got this sine theta value. If you remember, we said tan theta is the angle between two straight lines. So let me just write it down here. How we got sine theta, we are just doing it here. Tan theta equal to m1 minus m2 by 1 plus m1 m2. We know m1 equal to a1x plus b1y plus c1. So b1y equal to minus a1x or minus a1 by b1. m2 equal to minus a2 by b2. Tan theta, once you substitute m1 and m2 values, you will have m1, that is minus a1 by b1 plus a2 by b2 divided by 1 plus m1 m2, that is 1 plus a1 a2 divided by b1 b2. This is equal to tan theta equal to, you will have a2 by b2 minus a1 by b1. So that is a2 b1 minus a1 b2 divided by a1 a2 plus b1 b2. Now once we have tan theta equal to this, you can easily prove that sin theta equal to a1 b2 minus a2 b1 divided by square root of a1 square plus b1 square into square root of a2 square plus b2 square. Once we know tan theta equal to a1 b2 a2 b1 minus a1 b2 by a1 a2 plus b1 b2, you can easily find out sin theta, because once you know tan theta, you can draw the right triangle and you can keep the values and you can find out what is sin theta. So that sin theta value we have substituted here. So let me just summarize this, how we got this. Very interesting. We have been asked to find out the area of the parallelogram. They have given us all the equations of the four sides. We know that in parallelogram, opposite sides are equal and also parallel. So we have two pairs of parallel sides. That gives me immediately information that I can find out the height or altitudes very easily, because that is nothing but distance between two parallel lines. So that way I can find out P1 and P2. Now the problem only comes how to find out the base length. To find out the base length, I am leveraging that let the angle, one of the angle of the parallelogram be theta, and how I can use theta and P1 and P2 and convert the base either AB or AD or DC or BC into P1 P2. So once I have seen that area equal to AB into P1, we can take AB equal to CD, and from the triangle DXC you can see that sin theta equal to P2 by CD. So you got CD equal to P2 by sin theta and area equal to P1 P2 by sin theta. Now this is simple straightforward substitution. We know P1 equal to C1 minus D1 by root of A1 square plus B1 square. P2 equal to C2 minus D2 by root of A2 square plus B2 square. Sin theta value we have substituted, but how we got the sin theta value? Since we said one of the angles of the parallelogram is theta, it's nothing but the angle tan of that is m1 minus m2 by 1 plus m1 m2, where m1 is the slope of CD and m2 is the slope of BC. So from tan theta I can find out sin theta. That's nothing but equal to what we have substituted in the last step. So the area of parallelogram, if given that the sides are with equations a1x plus b1y plus c1 is 0 and plus d1 is 0, one pair of parallel sides, another is a2x plus b2y plus c2 equal to 0 and a2x plus b2y plus d2 equal to 0, then the area of parallelogram is very simple, c1 minus d1 into c2 minus d2 by square root of a1 square plus b1 square into square root of a2 square plus b2 square. In the next session, we will try to do some simple examples based on this area of parallelogram. Thanks for your time. Bye for now.